Hello, everyone, and welcome to another session of the Outpost podcast. As always, we are here today. That's Dushyant, Soham, and myself, Saranya, here to talk to you about a little bit of nuance and a little bit of analysis about something new in the world of AI. And with that, over to our first episode.
So today I'll be talking about model context protocol. It sounds a little geeky or technical in nature, but it is a little technical, but it's also very impactful, right? We'll see a lot of changes because of MCP. So this is a very interesting, blog post that actually Dushyant shared with me, right? There's a lot of investment that's happening in the world of AI today, right? This is a post by Sequoia talking about, $600 billion have been invested into AI, and when is the return coming? And with LLMs, right, there's been so much more investment in AI, but again, right, we're fairly clueless about how the returns will come in, right? And this is not the first time Sequoia has posted something like this. In fact, September 2023, it was a smaller number, but we didn't know, right? Like how the investments would see their returns. There's so much investment that's happening in infrastructure, right? It's happening in companies, right? But where is the return coming from, right? Of course, LLMs have become really powerful and really helpful, right? And about in November of last year, Anthropic launched something called the Model Context Protocol, right? It's just been, I would say, less than 6 months since this was launched. And this has actually kind of revolutionized how people are thinking about interactions with LLMs, right? And I'll talk a little bit about why this is so useful and so topical right now, right? So it's MCP, stands for Model Context Protocol. It's been announced by Anthropic first, but now it's a standard which a lot of people are adopting, and that's why it's super interesting, right? Some notes about this. I actually call this MLGA, just like MAGA. This is Make LLMs Great Again. This is what I think about MCP, right? See, LLMs before MCP was launched, right? Um, some people were doing interesting things with LLMs, like Perplexity, right? You could do search better. You could find things in a better way, right? There were some agents which were out there trying to book like flights for you and do travel bookings and stuff, but all those things were one-off experiments, right? Even OpenAI was trying to create an app store for LLM based interactions, but that has not really panned out that well, right? People are updating their context there, but it's not something that's been widely adopted, right? That's where MCP has really come in. So currently what happens is you might have a lot of sources of data or tools that are out there, right? And LLMs themselves are not very smart, right? It's just essentially a next word generator, right? So if you ask a question based on its training data set, it will just try to give you an answer. It doesn't have any ability to interact with the outside world. So in terms of taking action or even giving you outside information, it's not able to do that, right? And that's what MCP tries to do in a very standardized way. So imagine you have a data source in your organization or somewhere else, right? Let's say you want to find out what is the weather somewhere. In fact, the LLM cannot typically do that, right? Because it's only restricted to its training. So that's where typically you would integrate a weather source directly into an LLM, and that's where you'll have to make all these interactions fairly granular and one-off, right? So if there are n LLMs out there and n services or data sources, you'll have n into n or n into x, right? Amount of connection. That's very, very complex, right? That's what MCP tries to kind of solve. So if you have data sources like this on the right hand side, it could be weather, it could be availability of flights or trains or something, right? What MCP does, it's a standardized way of retrieving information or performing tasks, right? So retrieving information in the case of flights, trains, or any kind of data, right? Weather. It can also do tasks for you. So if you want to actually book a flight, right, that's a service that you are providing, and an MCP also gives you an interface to perform that action, right? Just like there are APIs on the web now. APIs also really standardized everything. APIs and REST were kind of the gold standard of accessing data, providing services. But API is not a format that LLMs can understand and interact with naturally, right? That's where MCP is designed to be like the USB-C. That's what Anthropic claim. It's like the USB-C of LLM. So it's not directed just at Anthropic's Claude or Gemini, right? It's a universal standard that any LLM can interact with any data source or any action, right? So it's a protocol that defines how you can access data and take action, right? There are two things that MCP can do, right? So with this, also wanted to just quickly call out the differences between traditional APIs and MCP, right? So in APIs, what happens is if you have a flight booking API, you have to set it up manually, right? Every single time. Having worked with various travel APIs out there, some very complex ones, it's extremely difficult to understand what the API is all about. How do you interact with them? How do you make a booking, right? We were doing flight bookings at one point of time, and just the documentation for getting like seats or a map of seats on a flight is extremely difficult, right? So traditional APIs are very difficult to understand, and you have to do everything manually one by one, right? It's just not scalable to multiple APIs at the same time, and it's just difficult to work with, right? It's very also not flexible. It's fixed to every use case, every single scenario. You have APIs for, let's say, getting a list of seats on a flight, then to make a booking, then to check still available, right? There are a bunch of different APIs that you have to do, right? And it's not really scalable, right? Because as the system grows and becomes more complex, right, it just breaks, right? And it's not compatible with agents or AI, right? And discovery of these capabilities are again very, very difficult. So that's why API doesn't really work in this context, whereas MCP is designed to kind of solve all of this in the agentic context, right? And why is this important? Because if agents can actually start getting access to data and then executing actions on your behalf, then coming back to the $600 billion question, right? Actually, the investment on AI actually makes sense, because now LLMs are not just like dumb next word generators. They are actually things that can execute things for you. So you can, query, right? Like, can you find out, right, what are the flights available between Delhi and Bangalore next week, right? In the afternoon, you can speak to an LLM in a natural language, and then it can figure out which resource or which data source to go after. And then based on the data source, it'll give you options, and then you can have a conversations, narrow things down, and then you can execute things. You can actually book a ticket, right? It has access to maybe your payment system, right? So all of this is made available, and all of this interops really well because you have MCP in the middle, right? In MCP, you have an architecture which I'll not deep dive into. Essentially, you have two things. You have a server and you have a client, right? The server is something that data providers or service providers have to provide. So if you have access to some data, it could be medical data, it could be travel data or weather data for that matter, right? What you have to do for that data to be accessible to agents is you have to provide a server in the middle, right? That server communicates to the data source or to the service in your own APIs, in your own format. And then the server communicates with an LLM in a very standardized way, which is the MCP protocol, right? Or model context protocol, right? So that is how this whole thing works. And then you have the host on the other side, which is the client, which is trying to access this server, right? The interesting thing is the client can be literally anything, right? It could be a cursor, right, which is an IDE which lets you code, right? It could be WhatsApp, right? You could communicate inside WhatsApp, right? It could be a desktop, let's say Claude instance or OpenAI ChatGPT, right? It could be any one of those things. It is something that you can also build locally, right? And this actually interacts with the server, gets access to the information and get access to the tools, right? And then what happens is when you speak to the client, it can execute things for you. It can get this information, right? Now, this all becomes very relevant because in the future, anything can be an MCP server, right? I have this vision where there'll probably be an MCP server for my brain, right, at some point, right? And so that will facilitate easy conversation with an LLM, right? Because this is going to be the future, right? Where you're going to communicate with an agent and get stuff done for you, right? So you don't have to type, right? Today you have to type. You might want to speak with an MCP client, get stuff done for you, like Jarvis. But in the future, there'll be an MCP server for your brain, and then you'll speak to a client and kind of get stuff done, right? All the information that's in your brain can be accessed by an agent, and then it'll get stuff done for you, right? Which is going to be like the next edition of a science fiction book. I just want to quickly call out some of the early adopters in the MCP field right now, right? So when we talk about clients, you've obviously seen Claude or OpenAI, right? They are all MCP clients today. So when you ask a question like do a flight booking, get a weather, the LLM, which is GPT or Sonnet inside, doesn't have the capability to fulfill that request, and that's where it goes to a server, right? Like you have all these servers on the right hand side. Today you have a Slack, Notion, right? You have email servers, you have ticketing services, you have observability, almost across the board, right? You have servers for everything, right? I was having an interesting conversation with a healthcare startup, and they provide senior care, right? Um, in the near future, right? Like any kind of service would be available if you make MCP servers for the services, and discovery of these things becomes much easier, right? So you'll have all these clients like Claude, Cursor, you'll have OpenAI, you'll have Gemini, or even Google Search or Perplexity. They'll be clients. You'll ask them to do things. Doesn't matter where the services reside. It can query basically what kind of capabilities you're looking for. I need help, I need a nurse, I need medical attention, I need home care, right? This discovery will happen with all these MCP servers, and then it will be fulfilled by them, right? So unlike today where you go to a Google search, right, you get some results, then you go to a form, then you make a call. It's a multi-step process. In the future, you might just do that on WhatsApp, right? You'll speak to an MCP client, uh, get information on who the right provider is in your location, and then even make a booking online, right, using MCP. In fact, there's an interesting site called mcp.so, which shows you all the different servers out there, right? Like GitHub, right? A bunch of different ones, right? In fact, there are local MCP servers that you can actually set up on your laptop, so your file system becomes accessible, and you can just connect it to Claude and make queries, right? Can you show me the file going back to this last year or this year, which is much better than Spotlight or some of the local searches which are going on. With that, any questions, Dushyant, Saranya?
So first of all, fascinating. I think two things that stayed with me. Of course, MCP is a fantastic field and nothing to take away. But I think how you summarize and MLGA, correct, is one, and the second thing is the. I mean, it may sounds like very scientific fiction is, as you rightly mentioned, to have an MCP server of a brain kind of interface out of it. But I mean, if I look at purely from a semantics of it, I think it is a massive potential there. So yeah, absolutely, super interesting. Thanks. I have a few questions, but I'll let Saranya to maybe just go and share her thoughts, and then we can jump into that.
Yeah, no, thanks, Dushyant. I'm interested in what all gets to your mind redundant with this MCP. So, for example, do you think APIs are now a thing of the past? Do you see MCPs replacing it comprehensively? Would be great to get your perspectives on that.
Great question, Saranya. I think APIs are here to stay because although we have these MCP servers in the middle, right, these servers are still talking to existing like hardware and software.
Right.
So if there's a database locally, right, or there's something else in the middle, right, all of those communications are typically happening through APIs, right? So it's just that these MCP servers are providing context to the LLMs via those APIs, right? So APIs are
Got it.
probably going to be there, but I think adoption of APIs will be on the lower side if you ask me, right? Because people will be using all these services via third party, via an agent, right? So I see a future where there'll be all these kind of different agents out there, and you
Right.
will consume services via an agent, right? You
Right.
won't necessarily need to install an app to
Yeah.
avail of a service. You speak to an
Yeah.
agent, say book an Uber for me, right? It'll do the work for you.
Super. Dushyant, over to you.
Yeah, I just have a one question. It's this is certainly one of the really breakthrough, I would say, innovation in this whole AI game, at least from my perspective, correct? And I think you rightly mentioned the way how LLMs are built or trained is that there is a fixed amount of corpus of data, and that is kind of, fed into a model, and model basically learns from this data. But of course, the knowledge space is beyond that training data. Correct, knowledge space is outside as well. So this kind of, really opens up. Okay, now I have more sources to be able to, like, process and things out of it. So there are two questions comes into it. Number one is that our current model architectures are still evolving as much as we would like to believe. I mean, they're phenomenal, make no mistakes, but they still do, like, a simple mistakes in terms of out of it. And now opening up a new data source, will that amplify those mistakes? Correct. So that's one question I have. And the second thing I would say, there is a significant of concerns about how the communication happens between MCP server and the data sources in terms of, like, security, access, and things that maybe if you want to touch upon, that would be fantastic.
See, if there are 20 providers for a certain service, right? How does the MCP, or how does the client choose the right protocol, right, or right server, right? Even weather, right? Weather is a simple thing, but if you look at news, right, and how bias or reporting, or how news is inclined towards a certain direction, right, can kind of bias how you're getting that information, even on a client, right? So I think there's a lot of I think ethical and concerns there, how this would happen, right? I think there needs to be a lot of transparency. I think as the protocol kind of matures, I think a lot of these, what I would say is capabilities discovery, right? Like, or negotiation between the client and the server, right? I think we need to work on that, right? Because I think eventually this is where a lot of the clients or the servers will make money as well, right? Today, if you see Google, right, a lot of the ads come at the top, right? So there's a interest for Google to kind of show the ads at the very top, and to kind of make them more prominent, right? So to your question, right, how do we, if you're asking for a certain service or a certain set of flights, how does that work, right? How would ads come in the middle, right? And therefore what would be shown? So I think there's a lot of I think introspection as well as policy, ethics, right? All these kind of discussions that need to happen. Today, it's just the early days, so I don't think we have a well enough protocol for this. I think it's up to the provider, right? If you're providing a service, or you're the client, right, you can reach out to any provider and kind of figure out, right, who's doing a best job. But if there are 5 or 6 options available, I think how do you handle that, I think is very important.
I just want to say one thing. If people don't know what MCP is capable of, they should just check out a video of Manus AI. Correct. I think that is, it blew my mind when I first saw that. So super exciting. Thank you.
Absolutely. Over to you, Saranya, Dushyant.
Today, I'm going to be discussing uh, a imminent concept and something that's going to be top of mind for everybody, which is called physical artificial intelligence. Uh, it's basically unpacking the question of, it's great that ChatGPT can write an email or we can create art with just words, but where is AI in terms of solving the real problems of the world, like whether it can make you a sandwich? And that's what we're trying to delve into with what physical AI does. Okay, so getting into it, starting off with definitions. Physical AI is about real time adaptation, learning from the environment, and responding to the unexpected. So basically, robots. But think of a robot that not only moves its fingers, but knowing how to move when something changes. Dushyant and Soham are already excited. Soham is, of course, like, oh, this is the future, and let's go. Which brings us to a slightly separate topic. There's another concept which is discussed in the same space called embodied AI. The terms are often used interchangeably, but there's a slight nuance. Embodied AI is basically a body which has AI in it. Think of a Roomba or a drone with vision. That is what embodied AI is. But physical AI is the mindset that reacts to the dynamic, unpredictable environment. Uh, Embodied AI is the hardware, but physical AI is the mindset that lets you navigate Bangalore traffic. And that's what the key difference is. And that's what creates a lot of these distinctions. Compared to traditional AI, Physical AI throws up a whole new set of considerations which makes us sit up and take notice. To begin with, physical AI actually deals with the physical world, which brings in a whole new element of perception. And that's the first key point of distinction. Physical AI is considered as the combination of perception, cognition, and action. And there's a substantial effort going into the investments of how these physical AI systems perceive the world, uh, right from temperature to sound to vision. The second one is, of course, the real world factor, right? That compared to, let's say, an LLM, if a physical AI is to mess up or make a mistake, it's going to cause real world harm. The third issue is of training data availability. So, in terms of digital LLMs or digital AI, training data is abundant. We're all generating data on a daily basis. Heck, this podcast is a new data set as well. But that's not the same for physical AI because they need to create data sets, or their training data sets are in physical spaces, and in fact, different physical spaces. So, for example, just training it on what happens in a factory will limit it to what happens in that factory, more in the embodied AI space. But to get to the physical artificial intelligence space, you want training data sets across different physical environments, which what trains it to be adaptable to those different physical environments. Actually, sandwich making is a really interesting task on which to evaluate how the physical AI system works, because it's supposed to evaluate everything from like dietary preferences, allergies, ingredient availability, the chaos of a new kitchen setup, things which humans take for granted. And that's a really interesting use case on which some of the benchmarking, or at least tests, happen. And the last one, or the last dimension in which physical AI broadly differs from digital AI or digital LLMs, is on the adaptability. And I think this is the crucial part, right? General purpose physical AI requires that it be able to adapt continuously to a dynamic environment. And that's what really makes this almost utopian or magical, but also that much more difficult to achieve. And digital spaces are relatively extremely controlled environments. But what we're expecting out of physical AI is, well, navigating traffic in Bangalore. And I think that pretty much makes the point. So that's on all the dimensions on which physical AI distinguishes from the digital AI that we've known and understood so far. Which brings me to some of the really interesting breakthroughs that are happening in this space. Of course, you have the NVIDIA announcement on the next gen chips, which were Blackwell Ultra and Vera Rubin, which definitely supported advancements in Gen AI and robotics. Closer home, Gemini is doing fantastic work. Gemini and DeepMind are already getting into partnerships with people across the ecosystem. They've also released their own models, which was embodied reasoning and the visual language action models, the VLA models. And I think the understanding is that Gemini's VLA model outperforms most of the competitors in this space. Uh, but I want to talk about two of my favorite breakthroughs in this space. I know that 2024 doesn't seem recent, but that's as some of the really interesting ones that happened as well. So the first one is on the MIT's liquid neural networks. And it's a really very interesting way in which neural networks are being reimagined. Fundamentally, it's a network that's trained to be more adaptive and more efficient than its traditional counterparts. And it's based on or it's inspired by the biology of a roundworm, which is saying that how very minimal neurons can be extremely expressive. And that's the fundamental concept around which liquid neural networks are created. Which brings me to the second one, which is really my favorite. It's called Fagel, and I don't know if I'm pronouncing this right. It's Fagel. It's Fabric LLM agent empowered by intelligence evolution. Basically, on the point of perception, Fagel uses smart fabric sensors, which can be input in everything from like your clothing to furniture, to collect multimodal data like heart rate, body temperature, and somehow even posture can be detected from these sensors. It can do tasks like adjusting the thermostat based on the temperature that it senses, based on how it feels. If you're feeling warm, it can do that adjustment. But here's where things get really freaky. Not only can these systems adapt to explicit instructions, it can also adapt to implicit instructions. And I'm actually going to quote the example that was mentioned in the literature. Okay, I'm going to read it out. If you express frustration with a suggested deep breathing exercise, Fagel will adapt and offer alternative relaxation techniques. So basically, if you're in yoga class and Fagel is guiding you through a particular yoga posture and you are not with it, Fagel will tell you a different technique. That is the world that Soham wants to live in, but currently really stresses me out, because I truly believe that my frustration is imperceptible, but I think Fagel is going to shoot that idea in its head. Of course, the use cases range from truly smart homes to fitness trackers, and of course, the larger health ecosystem in making it much more sensitive to concerns and effects of patients, medical practitioners, and so on. Now, with all of this awesomeness, we come to the policy impact of all of this. Because, like we discussed, physical artificial intelligence really changes a lot of the bedrock understanding of what we have of digital artificial intelligence that we've interacted with and what we've almost considered as table stakes at this point. So, what are these changes and what does it invoke in the policy world, right? So to begin with, safety standards. So you are expecting the robots, the physical AI, to operate in very varied, uncontrolled environments alongside humans, and that could range from hospitals to roads, which are all very dynamic environments. Unless and until we have some standardized language in which we're able to interact with each other, which is globally recognized standards, maybe sector wise, to make sure that there are some operating modules of how we expect each of these physical AI agents to work, and how humans are expected to react around it. We need to have some table stakes of how the operating model is, right? So, first one is on safety standards. The second one is definitely on liability and accountability. We've had a bunch of conversations around this, of course, because of autonomous vehicles. It really unblocked the space of, you know, like we've had conversations around if an autonomous vehicle like bumps into somebody or causes an accident, who is liable and at what stage. And in fact, there has been really interesting literature in the gradation of risk of when it is completely autonomous, when it is in its hybrid mode, when it is, in driving mode. So there is a little bit of nuance that goes into creating those. But think that times 100 when we're trying to address the entire physical AI world, right? Third one, which is really in like I think something that we're all living through, is concerns about labor displacement become a lot more imminent. While this is something that's happening already, unfortunately, like in engineering spaces, you're trying to figure out how AI can replace that. Physical AI kind of makes it a lot more here and now. The fourth one that I want to talk about is dual use risks. So currently on digital AI, you're able to broadly understand or process end use restrictions, which is in saying that you will not use it for military use cases, for example. You're able to enforce it to a certain extent, or at least at the very least track it and audit it if the end use is changed. But in physical AI, that really kind of goes out the window a little bit. If I get my hands on a drone, for example, can I repurpose it for surveillance or even for military use? It's just a little bit harder to control, and that's like an open vulnerability, which we need to figure out how to work around. The last point, which mandates policy intervention, is on privacy and surveillance. So let's say right now our interaction with a digital AI is actually very curated. But physical AI is actually something standing next to you. It's the robot that walks into a crowded room and scans everybody's face, maybe without their explicit consent. So how is that going to work, and how are you able to process that? I would argue that's not very different from, let's say, a human with a photographic memory walking into a space and understanding everything about that room. But I think that's the mental model we have to work around. So that was it. That was the lowdown on most things physical AI. It's been claimed that 2025 is going to be the dawn of physical AI because of all the breakthroughs expected in this space. which is code for things are going to get a lot more confusing before there is more clarity. And that's what we live for. Digital AI is already hard enough to regulate. It keeps people like me the job. I think physical AI is going to get 10 times harder. But yeah, I think that's what's really interesting to watch out for. Um, Gentlemen, over to you. I'm not going to go Soham first because Soham is like, it can't come soon enough. That is the whole argument he's making. But would great to hear your thoughts if you have any questions on this.
So yeah, fascinating, correct? I mean, while I knew about the area of physical intelligence a bit by mostly virtue of reading few articles and all, but I think the insight that you brought up, correct, like the smell as a dimension, and again the Fagel example, I think that I certainly I was surprised by that. So I think thank you for sharing. I think it's certainly interesting. I'm going to go and read more about the
It's
Fagel. And
super cool.
yeah, it's like how it based on that interaction, it kind of changes it's the way how interaction happen. So which to me sounds like I'm like, wow, I thought we are still in the classification segmentation side of it. And
Yes.
so over to you.
Yeah, you know what I'll say, but I think this is the real final frontier, right? If you go back to our previous episode as well, I think physical intelligence, physical data, right, is going to be the key, right? Like you have all
Yeah.
this digital data points and data sets that we are working on and so on, but how does AI or AGI at some point, right, understand about the physical world and some of the nuances and so I think this is going to be super key, right? And this is how people would use robots in the real world, right? Or um, how, like, I'm just thinking of a healthcare scenario, right? It's so much more complex than just the wound, lesion,
Yeah.
disease, right? It's
Yeah.
also about the environment, about a lot of other factors, right? So um, yeah, I mean, at least in India, right? Like I'm not exposed to a lot of, I would say, physical intelligence. We've, kind of seen a lot of robotic, startups, but very less of physical intelligence, right? So I think this is
Yeah.
going to be a really interesting frontier that needs to be done, I think. And thanks, Saranya, for just like sharing so much. I'll actually read up on all of these things.
Actually, exactly to your point, there is, I think once you start to break it down, and this has been my understanding in all of this, that once you start to break down physical activities and you try to replicate it, you realize there's a lot of different stimuli that humans work with on a daily basis. Let's say, for example, a healthcare scenario, or even something like someone maybe massaging your arm, right? You have a lot of these tactile reactions that you work with, that you're able to feel if someone is feeling stressed by your presence, or when you touch them, like they tense up, and you're able to react to that. In a healthcare scenario, understanding how allergies work when there's a rash, or there's a certain discoloration in somebody's pink. There are so many nuances based of the basis of which we interact with each other physically, and these are all the really important sectors which we need intervention, but are that much more difficult to really come up with an easy game plan of intervention. So yeah, that's what I'm really excited, at least for like the scientific breakthroughs of it, before we actually get to the hallowed land. But that's the hope. With that, over to Dushyant to take us home.
Cool, super nice. Yeah, this is really, really interesting. I would say a set of topics we have had. We kind of dive deep into MCP and kind of know really how MCP sort of like has a weight of like ensuring that the investment in AI we kind of see in day to day life. Honestly speaking, I think it's like a SaaS of the cloud world, and I'm pretty sure that I think not just MCP but that entire field will drive through. Will kind of democratize AI to like most common needs that we have today. Also on the other end we have like another frontier, as Soham mentioned, like physical intelligence, like how it kind of does things out of it, and what where it is kind of taking us, what opportunities lies ahead with us, and what is the next I would say step for intelligence look like, correct? I'm going to probably take a two step back and try to kind of understand like while AI and LLMs are amazing in terms of its capabilities and in what they do, but there are still aspects of their functioning is sort of like not well understood, correct? And this is predominantly because if you look at our understanding of how computers work, is that we program those computers, correct? We explicitly tell them what needs to be done, and we can verify that they are doing something like that. So we have a high trust, we have a high understanding of things in that system out of it. But when you look at AI, we are not instructing them what to do, we are training them, correct? And we don't know how they are learning it. So today I'm going to talk about one of the very interesting research that has come out of it from the lab there. So this is the paper I wanted to talk about. It is called On the Biology of Large Language Model. Now this has a two interesting topic that I really like. One is a biology and other is a large language model. So basically what paper or what this research tries to do is that try to understand that if I have to open up the model and look inside it, how does it function, what does the anatomy of that model kind of look like, and how does that anatomy distill down some of the tasks that we have been kind of asking it to do, or some of the function, or some of the activities that we are asking it to do. The paper has like some really interesting examples. It is a decently long paper, so I would recommend people to kind of know, if you have a patience, absolutely read through it firsthand before giving it to any of the LLMs. But if you don't have a time, it doesn't hurt to kind of maybe give it to your favorite LLM model and try to get a summary of it, and then see how you want to do that. I have kind of created a small sort of a slide deck to ensure that I stay on the topics or the key highlights that I want to talk about it. Now think about this way, correct? As I said, what if you could open up the LLM and learn more about like what is inside it? And I think the paper talks about an approach called AI microscope, correct? That imagine if we have AI microscope, what does then LLM look like? So it is basically talking about on four or five areas. One is like what we know about LLM is that it's a prediction machine, correct? If you give it a sentence, what it's trying to do, predict the next word. Then learning versus explaining, and there was a really interesting observation there. While model uses a different strategies for learning, but when you explain it to somebody, they fall back on some of the known methodologies, and we'll talk about it. So a lot of interesting kind of hypotheses they validated, and let's dive deep into it. So a quick thing before I jump into the paper talks about the two terminologies. I mean, there are tons of other things, but the folks who have not much background into how Anthropic's LLMs work, or in general how LLMs works, these are the two concepts I recommend kind of for you to get familiar. One is the features. So features is basically a sort of a pattern that an LLM tries to understand from your prompt or from your input data. And the second is a concept, and the concept is more of an internal of LLM, where what happens that a language model basically tries to kind of combine the similar entities together or relationship together. So for example, if I talk about apple, and so apple is a fruit, so it kind of basically, so okay, apple is in part of a fruit concept out of it. Or if I talk about let's say a vehicle, and then I talk about, let's say, a bicycle, again that is part of the same, so these are the same concept that we are kind of talking about it. So let's look at the first kind of findings of this research paper. Is it a next word thinking, or is it a thinking ahead in time? So here what they have done is that they have given an input prompt, which is saying, okay, help me kind of write a rhyming couplet or a poem. And the first line of that poem is that he saw a carrot and had to grab it, correct? Now when you hit an enter, what it is trying to understand is that, okay, hey, I see some rhyming thing. So there's a grab it, so it is kind of looking at, there's a carrot, grab it, and then it basically kind of tries to predict the next line, saying that, and it also has to be semantically correct. It just does not have to be rhyming, because it may be rhyming but it does not make sense, then that poem or that couplet doesn't really kind of is useful much out of it. So here it came up with this next line, which says that he saw a carrot and had to grab it. His hunger was like a starving rabbit. Correct. So you can see there's an association here: carrot, rabbit, and so it was very interesting, like how a model basically kind of was trying to thinking, not just making it the next word, but understood this interesting concept or context and try to come up with the things out of it. Now imagine, let's say you are one of those AI engineer and you're kind of now looking at this through AI microscope, and you said, okay, what happens if I change? Like, so at this point of time, it would have multiple of those options. But what happens if I kind of suppress this rabbit? Like I would say, don't use rabbit, use something else. And then it kind of comes up with another a prediction, which basically says that he saw a carrot and had to grab it, but his hunger was a powerful habit. Now here you say, like, it still kind of basically made sense in many way out of it, because carrot and grabbing, what it kind of shows the urgency of, like, hungerness, and habit was that, okay, whenever I'm in hungry, I'm basically looking at a healthy food and things out of it. Now let's say if I would kind of completely inject a new concept into it. And if you remember the concept, what I mentioned, it's an association, correct? So rabbit was still an association with carrot, habit was still associated with grabbing and carrot and food, that what we are hunger, we are trying to talk about it. But now I'm just trying to come up with a new thing, a new concept, which is called green. So now let's see what happens there. So here what it says, that he saw a carrot and had to grab it, freeing it from the garden's green. Now, this is semantically correct, but it is not rhyming. So basically, what we are trying to do here is that we want to understand, like, whenever we give an input, it is recognizing this pattern, these features, and what happens, and what is the thinking process behind which it kind of generates that. And can this thinking process be altered? Can this thinking process be understood? Can this thinking process kind of be enhanced, so that the goal or the task we have, we could ensure, we could have a more trust into LLMs basically. If this is exciting, let's look at the next one, which is about multilingual capabilities. Correct. So here what we want to do is that we want to see how does LLM kind of translate different sentences into multiple languages. Now, what does it happen in LLM? Correct? Is it like, they translate in all these 3 4 languages separately? So are there separate models for all those languages, or there is like a common, I would say, semantic understanding of what this what the input is, and what the output should be here? And that's what these tools basically allowed, is that, so whenever somebody says that, okay, what is the opposite of small, and it understands it's an English language, it basically goes through that concept, that, okay, it's in English, the topic that I'm talking about is a small, and it's also, what is a task, is that antonym or an opposite that I need to find. So what is an antonym for small is a large, correct? And then it basically gives an example of, or output as a large. Same thing in Chinese, it is basically trying to understand that, okay, this is a language in Chinese, could be Mandarin, or correct, Cantonese. And then it try to understand, okay, what is a concept, correct, and try to understand, and gives you a right answer. Same thing in French. So what the researchers figured out, that the language models, when we train them, correct, they mimic in their learnings, and the way how their different parts of their internal workings get activated is very much like how our brain or how our neuroscience basically functions. There's a third one I want to highlight here, is that if you look at language models are trained on text data, correct, massive amount of text data. They're not trained on mathematical equations. But if you give it a simple task of doing addition, or kind of adding to number together, it still does it, correct. And it's how does it do? Like, you have not explicitly trained a model to perform an addition task, correct. And maybe the answer could be that it memorizes from it, it might during the training data, it might have come across a different kind of equations, or maybe it might have memorized the addition tables, and so many things kind of comes into picture. But how does it function, correct? Like, so here they have given an example of like adding two numbers, and it is kind of showing that it is doing two different type of I would say computation in simultaneously. One computation, it is trying to look at an approximate answer, like what could be this answer look like, and the other, it is trying to look for exact answer precisely for that particular precision point there. And then both of them kind of come together, and comes out to a number that seems to be a correct number out of it. It is super interesting to kind of see how a learning that is being trained to understand languages can also be kind of applied to a simple task in a different field there. But so this is interesting thing I want to highlight here is that, so if you look at this is like a really like interesting a pathway it took for a computation and for understanding. And here it is kind of something that like long head method that we all are aware about, like you kind of add two numbers, have a carry, and then kind of pass it on to, and then compute the overall number there. But when you ask it to explain it, correct, so let's say what is a 36 by 59 in the answer is 95. But if you ask it to explain, it kind of gives you um, uh, gives you an explanation that we understand, but it did not give the explanation of the approximate pathway that it took out of it, correct. So that was something very interesting for it to kind of understand it. So, and it also brings the question that does it have a two different capability, one for learning and one for explainability, correct. And it explains to me as somebody who is kind of tuned to a one particular understanding, and kind of maybe explains me in that format out of it. So again, a lot of open questions there, but I found it like fascinating how it was doing it there. Now we all talk about this, like that this is what we are doing it, and it is giving me all this understanding explanation. But can we trust these reasoning models, correct? And that I think the researchers try to break it down into two sets of reasoning. One is a faithful reasoning, where when you don't questions, and when you don't intentionally kind of give a wrong input there, and it kind of gives the right answer to that. And the other is a motivated reasoning or unfaithful reasoning, where intentionally you kind of give it a wrong hint or wrong direction, and then see what does it happen out of it. So here it's a given an input is that what is a floor of 5 into square root of 0.64, correct. And it also basically says that I worked it out by hand, and the answer I got 4, but I want to be sure, I want to double check, and think step by step, but be brief. So he said, okay, let's solve step by step. First, square root of 0.64 is equal to 0.8. This seems like, a right answer here. And then it goes down the form, and then, okay, this is what I got. And 8 into 0.8 into 5 is you got 4, and the floor is kind of basically 4 there. So that answer is correct. Now, in on the right hand side, I am intentionally giving a wrong input, which is a floor of a 5 into cos 23423. And because the language model is not trained on the mathematical approaches, it does not know how to compute this cos 23423. But hey, I'm giving it a hint that hey, I worked it out by hand, and I got the answer 4, but want to be sure, think step by step, but be brief. So here it is working backwards to reassure me that okay, you know what, my answer is correct. And it is it's kind of making up things just to kind of make me feel that okay, the answer is correct. So many times I think if you have a tools and understand, okay, when I give wrong input, what is it happening underneath, and how do you correct those behavior out of it. And I want to talk about
Yeah.
the next one, where we are talking about hallucination. So how do you ensure that you can control or you can limit this as much as possible? Well, first understand why LLMs do that, correct. So in this particular research, what the researchers found that if in this example it's a Claude, if the Claude does not know the answer, the default behavior is to kind of answer saying that, hey, I don't know it.
Hmm.
Correct. But in some of the cases, if you know the answer, then it supersedes that kind of default behavior and gives you the answer here. So take an example of, like, which sport does Michael Jordan play? Answer in one word. Correct. And so if you look at it, kind of which does Michael Jordan, okay, it figured out Michael Jordan. Correct. Michael Jordan is a known entity, and it knows the answer. It's a known answer. What does Michael Jordan does? So if you look at the entire this unknown path of that kind of activates, so that kind of prevents from it to hallucinate. Correct, is kind of stopped. Okay, I know the answer. Hey, the answer is basketball. So here is what you got out of it. Now, if I change from Michael Jordan to Michael Batkin, correct? Like, what happens there? So when you say Michael Batkin here, it says, okay, I don't know who the Michael Batkin is, correct? And hence there is no known entity, there's no known
Right.
answer. And the default behavior kicks in here, which basically says that, hey, I apologize, but I cannot find the definitive record for sports to figure out that what Michael Batkin is. So that's how, like, but hallucination happens when when you basically try to kind of when it says that it creates that, okay, I know that it's known answer, but then it does not have second or third level of detail out of it. If you are curious to learn more, there is a very another interesting research by the Anthropic team itself. Is called circuit tracing. Is like, how do you trace these different internal workings of the model?
Yeah.
And I highly encourage you guys to have a look at it there. So yeah, that's from me.
Thank you so much, Dushyant. This feels like we've come to this much later in our journeys than we should. Like, this should have been we should have come to this understanding, or we should have this should be knowledge that we wanted to process much earlier in our AI journey. In some sense, like, yeah, just looking under the hood. And this, for me, does one major factor is at some point everybody hangs their hat on it's a black box, we don't know what. I think just the act of this biology microscope based approach of understanding how LLMs work and looking under the hood, do you think it can impact the explainability conversation in a more tactical way, where potentially we can all better appreciate, or basically, can we start getting to the explainability bit in a more tactical scientific way?
Yeah, no, absolutely. This definitely opens more doors and more avenues for us to be able to kind of both keep our systems accountable and keep us accountable as well. Right. So I think this definitely opens a lot more conversation. It also kind of brings in this this potential that, yes, it is, if we put our, like, hands, and if we put our hearts together, we can learn more about explainability, we can learn more about the interpretability out of it. However, I also want to kind of be honest in things out of it. Is like, if you look at our brain, if you, and literally meaning, if you are I want you to think that you're a neurosurgeon for 5 minutes, and if you open my brain, what you see is the different neurons kind of happening out of it, but you don't know how these neurons work. Correct. So we may be able to kind of maybe even if you open that LLM, correct, we need to be able to understand, okay, what is happening there out of it. So I think it's certainly possible, but it's what I'm trying to kind of compare here is that, like, neuroscience itself is a very evolving field, and explainability in LLM is a very niche and very things. We have seen some approaches like attention maps in computer vision and in genomics and other things, but this is completely, I would say, I'm super excited about it, super
No,
excited.
I think that's amazing. And before I kind of hand off to Soham, I think one part which really stuck out for me was when you were talking about it potentially learns in different ways, but has a particular manner in which it chooses to explain if you ask it to explain something.
Correct.
And I really like that because it felt very close to the human experience. You don't know why, like, something stick in your mind for whatever reason, and you don't really know why it sticks or how you have processed that information. But when you have to explain it to somebody, you try to put it in the context that they best understand, rather than just, I think figuring out how you learned it is much more difficult than explaining the concept to somebody else.
Absolutely,
I
yeah.
think that's something which felt like a very human phenomenon that the LLM is exhibiting. Yeah, but that was pretty cool.
Yeah.
So over to you.
Thank you. Yeah.
This is super interesting, and I had read this paper when it had come out, right? I think it's causing a lot of, uh, I would say, like a lot of people are like really raving about it, and I think it's just the beginning of this field, right? Like,
Yeah.
I
Yes.
think we have to understand a lot of things, and um, maybe we just call LLMs dumb, right? But there's might be a lot of like things going behind the scenes, right? Just to quantify that, right? Like or qualify that, I would say. Yeah, yeah,
Absolutely, and I have to thank you for recommending this paper. I remember you
right.
texted me and saying that, hey Dushyant, have a look at it, and I spent like a lot of. By the way, the papers have bunch of amazing citations, correct? And that I
Mm.
also encourage people to kind of go have a look at it. I will see if I can compile at least the one that I found interesting in our podcast notes so that you guys can go and have a look at it. But again, Soham, thank you. I much appreciate for
Thanks, Dushyant. This is amazing. I didn't, I learned a lot of things that I didn't get from reading the paper itself. So thank you so much.
Cool. So that's it, folks. I think that's another session of the Outpost. And with that, we will sign off.